Hello and welcome to the video on some probability examples. I wanted to do some examples because sometimes just watching the rules doesn't do it justice. You want to get some practice and you want to at least see a few problems done. So the first thing, let's talk about our rules. The probability has to be between 0 the probability has to be between 0 and 1. Okay, and the probability all the outcomes has to equal 1. Okay, and don't forget our complement. The probability of event not happening equals 1 minus the probability of it happening. Okay, for disjoint, the probability of A or B happening is the probability of A plus the probability of B. That's if your events are disjoint, and if your events are independent, the probability of A, oops, I got this backwards, that's an OR. It's not an AND. This is an OR. That's union. This is intersection. Of A and B equals the probability of A times the probability of B. Okay, so let's look at these real quick. Let's see if this is true. Yes, this is 5%, 10%, 20%, 50%, 10%, 5%. They're all between 0 and 1. Let's add them up. 50, 60, 70, 80, 90, and these two 5s equals 100. So that's true. Okay, let's add these up. Oh, let's see. 10%, 5%, 30%, 30%, 20%, 5%. So they're all between 0 and 1. Okay, so let's add them up. 30, 60, 70, 80, 90, and these two 5s make 1. So the first two are checked off. Okay, so let's talk about disjoint. Can you get a 15 and a 16 on one trial? Okay, do these overlap? Can you get both of these? No. So these events, the events of one trial is disjoint. So if it's disjoint, we know that A and B are not independent. But let's look at two trials. I could just give you this, okay? If you get a 15 and 1 has no basis on what you get. If one outcome doesn't affect the play for the next outcome, okay? So if you get a 6-17 on the first one and that doesn't necessarily give you an advantage on the next, okay? So that means that two trials are independent. Two consecutive trials. And I'm just telling you that, okay? And my score and your score is independent, meaning that we played totally different. I have nothing to do with your scores. Okay? So let's look at this. What's the probability you get an 18? So you scan, these are the probabilities. You just scan that over to 18. This is the score. That's the chance you're going to get it. So 0.5. Okay? So you can write this out. The probability that you obtain an 18 is approximately 0.5. What's the probability you don't get a 20? So this is this rule right here. It's the complement rule. What's the probability you don't get a 20? So that's 1 minus the probability that you will get a 20. Probability something doesn't happen is 1 minus the probability that it will happen. So it's 1 minus, which is 0.95. Okay. What's the probability I get a 16 or a 19? Remember, when you hear or, you want to add. Okay? Are these two events disjoint? Yes, since they're disjoint, it's the probability that I get a 16 plus the probability that I get a 19. Okay, so what's the probability I get a 16? Here's the scores. This is me. So it's going to be 5% or 0.05 plus the probability I get a 19, which is 0.2. So there is a 25% chance or a 0.25 chance. Okay? What's the probability you get a 15 and a 18? Okay, it should be a little bit more specific on your trial. So this is on one trial. One trial. Okay, so I want to show you that you cannot go use this formula here unless I specify 3 20s in a row. See, I don't say that. I don't say, I mean, it's a little vague, but you get a 15 and an 18 on one trial. That can't happen. That can't happen. So it's 0. There's no chance you could get both. Okay? So don't go and use this formula, probability of A and probability of B. It will be wrong. What's the probability I don't get a 17? I don't get a 17. That's 1 minus the probability that I will get a 17. This is me. So it's 1 minus, what's the probability I will get a 17 is 0.3. 1 minus 0.3 is 0.7. You guys should be good at complements. Okay? Knowing the rest, that'll get you to 1. It's like dealing with a dollar bill. It's like change. If you buy something for 30 cents and you give them $1, they're going to give you 70 cents back. Okay, what's the probability you get 3 20s in a row? Okay, so now I told you trials from trial to trial is independent. Okay, so getting a 20 on the first one doesn't change the fact that you'll get a 20 on the second one. So these are independent. So I use this rule. Okay, so all 3 of them in a row would be the probability you get a 20 times the probability you get a 20 times the probability you get a 20. So it's going to be 0.05 times 0.05 times 0.05. That's the chance. Okay, let's go to the next page with some more. It's the same problem. Same problem. Okay, just different questions. What's the probability I get an 18 and you get an 18? Okay? So if I get an 18 and you get an 18 and our scores are independent, the independent rule says that you multiply them. So it's a probability I get an 18 times the probability that you get an 18. Okay? So that's 0.3. Oops, I went to the wrong one. You get an 18. Okay? So 30% of 50% is 15%. Okay, what's the probability I get a 17 or a 20? Or is add. These are disjoint events. I can't get a 17 and a 20 in the same trial. So this is going to be the probability that I get a 17 plus the probability that I get a 20. Okay, so the probability I get a 17 is 0.3 plus the probability I get a 20 is 0.5. So that'd be 50, 80%. Okay, get real comfortable going from decimals to percents. Okay. Alright, and this is going to be a switch up of a problem. The probability that you make the light on 434 in Sand Lake is 15%. Okay, so what's the probability you're going to miss the light? The probability that you make it is 15%. The probability you're going to miss it is 1 minus the probability you're going to make it. Okay, so the complement of 15 is 85%. Okay, and while we're on complements, I'll just show you a little trick that I learned along the line. So let's say we have 0.56. You guys probably have methods already to know your complements, but complements, this has to add up to be 1. So you want to say 5 plus what gives me 9? That'd be 4. And then you say 6 plus what gives me 10? And that's 4. So the complement would be 4. So you could do this with big numbers too. So you have this long number and you want to know the complement. Okay, so the trick is all these numbers have to add up to be 9 and this one needs to add up to be 10. So I say, keep that. So I say 1 plus what gives me 9? 8, 7, 5, 2, 7, 2, 4. Okay? So what happens here, this is a fun little trick. So if I did the complement, which is 1 minus this, that's the complement. So 1 minus 0.124727. I should get this 87527, and this is 24, but they rounded. Somehow they rounded, but this is right. Let me just make sure. Oh, I see the problem. That should be a 3. That should be a 3. They just didn't take it out because 7 plus 3 gives. Oh, that's 10. They rounded it somehow. Okay? They rounded it. This is right. Okay? So it's just a little trick. Okay, what's the probability you make it 2 days in a row? And now look, 2 days in a row would be the probability of a make and a make. Okay, you make it and you make it. So each trial is independent of each other, meaning that you making it the first day isn't going to affect you missing it the second day, or missing it the first day doesn't increase the likelihood that you're going to make it the second day. So that's what independent means. Since we know they're independent, we can multiply. Okay, so let's pull this out. 0.15 times 0.15, 225. Okay, so there's about a 2% chance. Okay, what's the probability you miss it 5 days in a row? You miss it 5 days in a row. Okay, so this was actually, I don't want to get my M's mixed up. That's make. So this is the probability of that you miss the first day and miss the second day and miss the third day and miss the fourth day and miss the fifth day. The probability you miss them all. Okay, since we know each trial is independent, we can multiply all these. So this is going to be the probability that you miss. How many misses do I have? 1, 2, 3, 4, 5. Okay, what's the probability that we miss? The probability you miss a light is 0.85. Okay, how many of these 0.85s do we need to multiply? We need to multiply 5 of them. So 0.85 to the fifth. Okay, so that's the answer. Put that in your TI-83. Okay. Okay. What's the probability you make and miss and make and miss and make and make? Okay, so you make the first day, miss the second day, make the third day, miss the fourth day, and make the last day. So these are all independent, so you're allowed to multiply. Remember, the ands mean multiply. Okay, it's just going to be which formula you use. When they're not independent, we have a different formula. Okay, or let me see. Yeah. When they're exactly. When they're not independent, we have a different formula. Okay, so the probability, so it'd be probability of a make times the probability of a miss. Okay, and you just keep going back and forth. So sometimes when I do long ones, I draw little lines for my outcomes. And if they're independent, I multiply. Okay, so the probability that I make the light, this is a miss it. The probability I make it is 15%. The probability I miss it is 0.85. And I'm just going to go back and forth here. Okay, so let's get an answer here. 0.15 times 0.85 times 0.15 times 0.85 times 0.15. So less than 1%. Okay, 0.24%. Alright, so hopefully that kind of gives you an idea how to work with your disjoint or independent. They usually always tell you, or at least they'll tell you this one. This is your clue. When you hear independent, you should think multiply. When you hear disjoint, you think add. Okay? So that's it. Have a nice day.